Alright, example 6. In order to accumulate $8,000 by January 1st, 2006, quarterly payments are made into an account that pays 6% interest, compounded quarterly, so that makes it exciting because they match. First payment is on April 1st, 2005, and the last payment is July 1st, 2006. What is the size of each payment? Construct a table showing the interest credited to the account and the balance in the account on the days where the payment is made. Okay, so first thing we have to do is we have to figure out what's happening here. So we make our timeline. So first payment is April 1st, 2005, so 4105. And then these are quarterly, so the next one would be 7105. Okay? Last payment is 7106. And adds an unknown amount, and we're trying to accumulate 8,000, and our interest rate is 0.06 quarterly, so that tells us that I is 0.06 over 4. Okay, so before we can do anything, we have to figure out the size of that payment, so we're going to use R equals 8,000 times our I, 0.06 over 4, over 1 plus 0.06 over 4 to some power minus 1. So now we have to figure out what that power is. So we're doing a full year, and these are quarterly payments, so we're doing it in April, July, October, so that'd be 2004. And then in that second year, we're going to do it in January, April, and July. Okay, so that would be our 05. So that means we have 6 payments. Okay, so that means N is 6. So to the 6th. So plugging that in the calculator. We get 1,284 and 21 cents. Okay, and again we're going to do 21 cents because we're going to round up, because we got 0.201, and again we're going to round up the payments. Okay, so that part is done. Now we need to construct the table. So now our table, when we do a sinking fund table, we don't have 5 columns, we only have 4 columns. So our first column is going to be the payment number, just like before. And this time when we do the payment number, we don't need to have a 0 payment because we haven't deposited any money. So first deposit would be payment 1. So we just need 6. Okay, so we have payment 1 through 6. So that means I'm just going to fill out my table here. Okay, and then our second column is the deposit itself. Okay, that's the R we just found, and again that's going to be different for that last payment because we rounded it up. And then our next column is the interest, so that's similar. Okay, and then the last column is going to be the balance, just like before. So the only difference here is we don't have the principal, and otherwise it works the same. Okay, so when we make our first deposit, so 1284.21, it hasn't been sitting at all, so there's no interest. Okay, so now before, just like we did before with interest, this is going to be the balance times I. Okay, previous balance times I, but there's no previous balance, so it's going to be 0. Okay, but here this time the balance is going to be the interest plus the deposit, so that's a little different too. So interest plus deposit, and again that's because we're accumulating money, so we're going to add it together instead of when we were doing the amortization table we were trying to pay off a loan, so we were subtracting. Okay, so again real similar. So I'm going to take my calculator, just put it right here so you guys can see what I'm doing. So we're going to take 1284.21 plus 0. Well, we don't need to do that on calculator. That would just be 1284.21. Okay, so we don't have to do any work there. And now the second payment we make is going to be the same. And the interest we make on that, we're going to multiply it by our rate, so 0.06 over 4. And if you wanted to, you could totally make that your piece. So this time our interest is $19.26, because again we're going to round to the nearest penny for interest. And then we're just going to add this to the previous balance. Okay, previous balance. So this first one was interest plus deposit. The next one is going to be interest plus previous balance. So to get the balance, we're going to add the interest plus the deposit plus the previous balance. So we're adding all of it together, because again we're accumulating money. Okay, so I already have the interest plus the current payment, and now I'm going to add the next payment to that as well. So that's our new funds, is $25.87 and 68 cents. Okay. So our next deposit is going to be again that $12.84.21, because that's going to be the same. So you could fill those out early if you wanted to. That's going to be the same all the way down. Except that last deposit, again, we're going to work backwards for that last line. And then we're going to make our interest off of this value, so just like we did with the previous line. So we're going to take our current answer, and we're going to multiply it by our interest rate, 0.06 over 4. So this time our interest is going to earn $38.82. Because again we're going to round up to the nearest penny here. And then we're going to add that to $12.84.21 and the previous balance, $25.87.68. So then our new balance after that third deposit is $3,910.71. Okay, so now we're going to take 3,910.71. So notice here I'm starting with my previous balance. As is, I'm not going to keep rounding, because if I use that decimal from before, it's going to mess up this number, especially if my numbers are really big. Okay, because you're going to be thrown off by dollars or hundreds of dollars, so you want to be as precise as you can be here. 3,910.71 times 0.06 over 4. So this time we earn $58.66 in interest, and then we're going to add that to our payment and our previous balance. So we get 52, 53, 58. And then we do it again. So to do the next one, we're going to take our 52, 53, 58 and multiply it by our interest rate. And when we do that, you should get 78.80. And then to get our balance, we're going to add that previous balance, the deposit, and the interest all together. And in our calculator, you should get $6,616.59. And then working this last row, we're going to do a little different, because again our balance here, we're trying to get right on the nose at $8,000, and we're going to work backwards. So we're still going to find the interest just like we did with the amortization table. So we're going to take our 6,616 times 59 cents, and we're going to multiply that by our interest rate, 0.06 over 4. And when we do that, you should get $99.25, rounding to the nearest penny. And then instead of figuring our exact change here, what we're going to do is we're going to take off our balance so far and the interest. So this value right here is going to be 8,000 minus 1925 minus the previous balance, 66.59. And when we do that, we should get, again, around the same value. So this time we're going to get 284.16, so we're only 5 cents off. Okay, so that's your the amount you're trying to accumulate minus that interest, okay, minus the previous balance. That last line, because again, this is always going to be just a little bit off because we're rounding. And if we had rounded down to 20 cents, then this would be a little bit bigger instead of smaller. But that's really the only difference.